no? And so for this morning, no, for today, no, we will have our discussion on the electric potential, no? And what is this electric potential all about, no? Ano ni siya, no? So again, we always flash, no, this one, no? Here is a picture of a tower, no? Again, there are power lines there, no? If we kind of zoom it up, no? So this is again, no, a kind of electric generating plant, no? Most often in the Philippines, we refer to them as National Power Corporation, no? Amo na nga ito na gina-refer ni nga building, no? So this National Power Corporation generates electricity inside, no? Kung sa Iloilo ni siya, maybe this is PEDC, no? PEDC is the Panay, no? Development something, no? Then they generate again electricity inside, no, by using coal. So it's a coal-fired power plant, no? And there are wires there, no, from the plant and goes into this tower, no? If you see the tower there, that tower looks like an Eiffel Tower, but there are wirings beside it, no? Now, the point is, the electrical energy that we are generating here is very, very crucial today, no? In to everyone, no? So it has become a necessity, no? It's just like food, no? It's just like air, no? We could not think, no, of living without it, no? So if there is a power blackout or a power brownout, no? So suddenly, no, in the middle of the night, no, 12 midnight, there's a sudden, no, power failure, and you are sleeping there, no, fanning yourself with some kind of a cartoon, no, and then you fan yourself, no, you are already mumbling things, no, that are, no, maybe, no, you are already angry to the one, no, to Panay to the one, no, that provides electricity to Iloilo City, no? So unscheduled brownouts, no, we are always mad at it, no, because again, no, we realize that electrical energy has become a necessity in our daily life, no? How will we use our aircon, no? So if it's summertime and your house, no, is not really ventilated, no, there's very limited windows, no, and then there's no air blowing there or wind blowing, that if your aircon suddenly, no, does not work, no, you really could not sleep, no? So again, no, the importance of electrical energy, no? But how is it, no, that charges that we've learned earlier, no, they don't move, no? We've learned that charges are called electrostatics, no? Electro is for electron or maybe for charges. Static means at rest. These are charges that are at rest, no? Electrostatics, no? So what makes these charges move in this wire, no? What makes them flow in the wire, no? So that's a very, very good question, because again, no, when we use a certain plastic, no, last time, the one that we call as amber or any plastic material, when we charge it by rubbing, we know that the charges there simply, no, are held in only one place, no? They are accumulating, and the charges again are accumulating in only one area, no? They never move, no? So again, the thing about moving this electrical energy from this location to all the parts of Iloilo City, no, and even further, no? Actually, ang aton electrical energy source, we now have a grid, no? So it's a power grid already, no? And when I say power grid, there's a company there that connects, no, even the farthest power generating plants, like the ones that are found in Negros, no, and then they have a cable there that reaches Iloilo City, no? So they have a grid there, no, that supplies the city, no, even from other provinces or regions, no. So or I think, no, Negros is still part of region 6, no, but they have a wire there all the way, no, and still supplies us with electricity, no? So the point is, no, how did the energy there or charges there, no, travel at such long distances, no? And again, no, we will think and try to answer that, no, with the concept of electrical potential, no, or electric potential, no. Sorry, no, so kindly omit the word there, AL, no. So let us say, no, that a charged rubber balloon, no, is in an electric field, no. So when it moves, no, it gains kinetic energy, no. While moving, no, it loses potential energy, no. This is a situation that is analogous to a falling object, no, in a gravitational field, no, which is also losing energy, no, while gaining, no, kinetic energy, no. So in this lesson, now we will study how charges lose and maybe, no, gain potential energy, no. So kung may ara ako nga isa ka balloon, na charge nga balloon, no, then ang ina nga balloon has a potential, no, because of the field, the electric field that is in it, no. Now eventually the charge that are in that balloon will probably try to suddenly, no, gets repelled, no. Pwede lang sila maghulag, no, kay because maybe they are all positive charges and then they will try to run away from each other, no. So from their initial potential condition nga nagabilog lang sila, they would suddenly, no, try to travel, no, and then they gain, no, kinetic energy, no. Now we realize that when kinetic energy is created, the initial potential energy, no, will now reduce, no. Ang potential energy nagagamay, but ang iyang kinetic energy nagadako na naman, no. So again, no, charges eventually move, no, when they try to repel or move from each other, no. Pwede man nga butungon siya, no, so they will be attracted, no. There's going to be motion, no, in that way, no. Now again, no, let's try to imagine if we have several positive charge, no, objects, no, held close together, assuming that you have some kind of positive charges and then put it together with another positive charge and then get another positive charge, and then you have one big lump of positive charges, no. Now assuming that you were able to hold them intact first, no. Now again, no, by nature of their positive, no, charge, then they will push each other away, no. They will push one another away from each other, no. So they will fly apart, no, since they will repel each other, no. This shows that the positive charges, no, being close together, no, possess initially a potential energy, no. So some tanga nagatingaw pa sila, no, while they are with each other, gusto silang malagyom, have already an energy there, and we call that energy again, since they are not yet moving, to be potential energy. Now in this case, we can call that probably as maybe an electrical potential energy, no? Now by that time, no, that they are now ready to repel, then they will suddenly, no, explode or maybe, no, splinter apart, no, and there you go, no, everybody is in motion already, no. So we call that now as kinetic energy. They now gain, no, kinetic energy, no. So again, no, just like what we were talking about there earlier about this electrical energy, no, about the generating plants, no, the one that pushes them, no, to move away from each other is this energy. Now, there is an energy in the charge that allows them to travel, or maybe there is work, no, that is given to the charge, no. So again, no, we know that energy is a capacity to do work, no? So everything starts with energy first, no, before you let them, no, gain some kind of work, no. Again, so as they accelerate from each other, no, this potential energy is then converted to kinetic energy, no, and work is done, no, by the electric field, no. Let's look at an illustration here, no. This is 2.1, no? So initially you have some positive charges together, no, And then for some reason, again, no, you were able to bind them, no, or make them, no, come close, no, to each other. Now, while they are very close to each other, they now possess some sort of a potential energy. No? At any time, they will suddenly, no, repel each other. No? So there were 7 of them initially, and then eventually, when they now run away from each other, then all 7 will now repel, no, in different directions. No? So now they are in motion. No? So this is now what we call, no, the kinetic energy of the charge. No? So when charges do move, no, then again, no, something must have caused it to move. No? Ano ang rason nga nag-move sila? Again, no, because of their similar charges. No? So if we have 2 charged bodies A and B, no, connected by a conducting wire, no, another form of motion, no, will be when 2 bodies, no, A and B, no, are connected by a wire. No? There's a wire in between 2 charged bodies, no, and then one point of the charge is higher in potential and the other one is lower in potential, but they are attached, no, by a kind of a conductor or a wire. No? Now B, no, is a positive potential with respect to A. So meaning mas dako ang iyang potential energy sang isa, no, ang positive potential sang isa. Now therefore, no, ma-travel na karon ang isa ka charge nga ginbutang naton like an electron. No? So again, no, if A is relatively, no, of lower potential, no, than B, no. So kung may ara tadi karon electron, if we let an electron move, no, from A to B, no, then makadto na siya karon sa B, no, ang ini nga electron. No? So ang A therefore has a lower potential and B has a higher potential. So where will the electron go? It will travel from A towards B, no? Does it make sense, guys? So ma-repel di sa'yo kag ang ini nga electron will now be attracted to the positive charge, no? Now if charges from a negatively charged body A, no, flows to the ground, no? So kung ang ini nga A ibutang mo ni siya sa duta, no, then ang charge karon will travel from A to the ground, no? Kaya ang ground, guys, mas nubo pag na ang iya potential because we believe the potential of the ground is 0, no? So the ground has the lowest potential. Therefore, if any charge is attached to the ground, that charge will always travel to the ground, no? So manang ginambal nila nga may grounding wire, no? So the grounding wire, no, allows charges to always, no, dissipate or be discharged to the actual, no, ground, no, sa duta, no. So kita mo sa mga washing machine, no, a washing machine or a ref, pag bakal nyo na, no, may makita ka na sa likod yung may laba ang wire, no, and you realize nga this wire has no connection, di ni siya karon makadto, hindi man ni siya pwede nga ibutang mo sa plug, sa outlet, no. So what's the purpose of that wire, no? That wire is a grounding wire, no? We always put it on the ground, no? Kung may ara kada tubo, imong inang tubo ilubong mo na sa duta, and then therefore that wire will now be attached to the pipe, no, the metal pipe that is now connected to the ground. Ano iya purpose? If in case ang imo ref now will accumulate charges, hindi kaya ma-electric shock, no? Even if you hold the ref there, no, nothing will happen to you, no? Okay, do you follow me? So this is again, no, another illustration of a moving charge, no? So if the electron travels from A to B, then ang B na karon will have a higher potential compared to A, no? Now commonly, no, ang ini nga electric potential B, no, is illustrated by this equation, no? So it is always, no, work or the energy, no, divide by the amount of charge Q, no? Ang aton nga unit sang energy is joule, no, or sang work, it's always in joule. Ang aton unit sa charge nga Q is in coulomb, no? So ang unit nga work over charge is joule per coulomb. Ang isa ka joule per coulomb is equals to 1 volt, no? That's equals to 1 volt of a charge, no? So allow me to write that, no? So meaning electric potential, guys, no? We'll have a unit, no? So it is in terms of volt, no? So 1 volt is equal to, no, 1 joule of work, no, per coulomb, no, per 1 coulomb, no? So maybe the unit that the symbol that we will use for volt is V, J for joule, no, or energy, no, or work, and C for coulomb, no. Now the unit volt is joule per coulomb, no. Electric potential V is a scalar quantity, no. So work may be positive or negative, no. So depende, no. Negative work now means that the electric field does the work, no, like kaina, no. If you have all the positive charges together, then the electric field is the one that pushes the positive charges away from each other, no. That's a negative work, no. So the negative work is occurring now when charges have similar, no, signs, no. Now positive work naman niya is the one that we show in figure 2.2 earlier, no. So this is done by an external agent, no, that does the work, no. So the electric potential is at a point, no. The electric potential at a point is the work done by an external agent in bringing a unit positive charge, no, from a point of zero potential to that particular point, no? Okay, so but anyway, now this is our basic equation. So please remember this equation. Do you have a question, by the way? So V is work over charge, no? Sige, now let's pause for a question na, no? Anybody has a question? Clarification, guys. No question? So yeah, let's move on, and let me erase this. So another term that we will encounter is the electric potential difference, or merely, now we will just cut it short as potential difference na lang, no? Others will use the symbol PD, no, for potential difference. So how do charges move, no? Positive charges move from place of high electric potential, no, or near a positive charge, to a place of low, no, electric potential, no, or near a negative charge, no. Electrons, no, which are negative, no, move the other way around. So kay inaya, nakita natin na if there are two locations, no, so if there's one, no, a point of higher potential, and then there is a dalom, no, so you have your point of lower potential. So what we will see here is that the charge, no, is always traveling, no, if you are dealing with an electron, no. So an electron will always travel in this manner, no? Okay, so amo na, no? Amo ginayang direction sa aton nga electric aton nga work, no? So the potential difference is seen, no, because there are 2 points that are of varying, no, electric potential. In an electric field, the electric potential is usually, no, measured relative to the potential of the earth, no, which is assigned a zero value, no. Work is done, no, against the electric field with a positive charge, positive Q, no, is moved from a point of lower potential to a point of higher potential, no. So the potential difference there, no, is measured in terms also of volts, no. So the unit of this, no, this is also, no, having a unit, no, in volts, no. Now if 2 coulombs of charge, no, is moved between the same 2 points, no? So 2 joules of work is likewise done, no? So for 1 joule of work, no? So kung i-divide mo ang joule by coulomb, guys, so amo na nga ton nga unit nga number of volts. So kung nagadako ang work, nagadako man ang iyang number of volts, no? So kung gusto mo siya nga dako ang iya work nga maobra, din kinahanglan siya sang dako man nga naga-push sa aton charge. So the electric potential actually is the one that pushes the charge. It's some kind of a force, no? Sa aton physics 1, the one that moves a block, no, or a box is a force, no? So here we will have a term there, no, voltage or electric potential, no? So that one, no, causes the charges now to travel, no? So that answers our question earlier, no, nga ang charges nato nagahulag siya, no? Okay, so we will symbolize it possibly, no, with delta V. So here's delta V, no? We call it as the potential difference, no? So they have the inverted triangle there, no? So maybe there are two values, there are two potentials there that you're subtracting, no? Maybe you have some V sub A, no, and we have some V sub B, no, and then they have two different values there, no? So by virtue of their difference there, no, then they have this notation, no? They have this notation, by the way, that looks like, no, a triangle, no? Kinatupad na nila di sa aton nga V nga symbol. So that's a symbol for a subtraction process, no? So that's a delta symbol, and every time we see that, no, like sa aton temperature change, no, sa aton nga volume change last time, no, sa aton nga expansion, we always subtract two values, no? So here, no, we have two electric potential, and then their difference again, no, amounts to what we call a potential difference, no? So a potential difference is the work done in carrying, no, a unit positive charge from a point, no, nga nubuang iya potential pakadto sa dako nga potential, no? So amo nang movement yan, no? So there must be this charge key. So if you want to let this travel, no, to V sub 2, no? So the difference there, no, maybe, no, from V sub 1 to V sub 2, gusto tang iningak yung maghulag din, no? So therefore ang ina nga value is known as, no, delta V, no? So paano na maghulag ang charge da? Again, something must push it, no, and that something is known as the potential difference, no, from V1 to V sub 2, no? Now let's see paano gina-calculate naman niya ang ining electric potential V, no? So there are a lot of mathematics here, no, but between two given points, no, pwede ta na ako na ma-determine ang electric potential sa isa ka charge, no? And ang potential na lang anay, ng electric potential, no? So the electric potential actually, no, we can solve it by this equation, no? So aside from work over Q, our value for the electric potential V, no, is equated to this one, no? So our V value, no, so V can also be calculated by K, no, and we already know what's K, no. Last time we were able to get K, that's 9 times 10 to the 9, no? And then we simply divide this not by R square anymore, but simply by the unit R, no? Or symbol R, no? So why ta na gina-square ang iyang nga length, no? Okay, so wala na nga nga electric potential in terms of Q and in terms of its distance, no, from ang nga charge to a given point, no. So ano ko dong V, is it scalar or vector? So ang aton ko nga delta V, guys, it's a scalar quantity, no. Wala na yan siya kinahanglan sang